is introduce a cost of managing the group, a cooperation cost. That's why I call it C. C's for cost, C's for cooperation. And it's going to depend on the gap between the marginal price and 1. It's going to be convex in that. So the marginal cost here will be small when m's near 1. That's the nudge idea. It's not going to be hard to push people off the demand curve a little bit. But the further you're getting away from the demand curve, the more you're going to have to monitor them, the more you're going to have to punish deviance. And then we're going to assume that, okay, we're facing these costs. What does the group do? And what do I mean, what do they do? Where do they put M? Where do they put the quantity? And that's a simple program to state. People have some value of the good. There's a cost, including the cost to the people who suffer the externality. And then there's also a cooperation cost. And so that's going to be our equilibrium idea. Whatever M solves that, and then once you have the M, you take D of M to get the quantity. So in the picture, same picture as before. Oh no, this is with the positive externality. So I need to draw something missed. There we go. So the marginal private cost is still 1. It's a positive externality, so the social cost is less than that. And I want to show you the geometry of what I just laid out algebraically. What's going to be the equilibrium marginal value and quantity? And what I'm going to do is I'm going to start here at the kind of individual action quantity. And we know that nudging people away from that quantity is going to be easy in either direction. The left direction is not interesting. There's nobody who wants people to do less of this positive externality. But to the right, the marginal cost of getting to move them to the right at first is going to be 0. So what I'm going to do is draw a supply curve that kind of departs from the private marginal cost right at that point. And so that's what I draw in here. And there's the formula. That's from the previous page. That's done on M versus M. If you wanted to have M versus Q, you translate the M into Q using the D function, the inverse of the D function. And then the equilibrium is going to be where the marginal cost, the full marginal cost, recognizing that there's a marginal cost of cooperating, equals the marginal benefit of having this good. And that's the equilibrium. It's in between what people do with individual action versus the Coase or Pigou answer. What's wrong with the Pigou answer in this? In this setup, why, if you were at the Pigou quantity, d of 1 minus delta, why can you do better by cutting back? Yeah. People have the big arbitrage. They can, yeah. And then the value, even from the social perspective, the value of losing a unit when you're starting at E1 is nothing. Whereas the gain, where I have to cut back on my supervision of these people who are desperate to try to arbitrage, is a lot. So I want to cut back. Convex. Doesn't have to be a quadratic, but third power would be fine, something. Well, we could work through an analysis where it's not that way. Now, we kind of have the presumption that these kind of costs are convex that we talked about on Monday. Well, if this one sloped down, that would be different. Convex means that this slopes up more than the baseline one. What's that green area? As an economic interpretation. It's a geometric object, of course, but what's its economic interpretation? Never know I could have so many stumped questions on just a supply and demand picture. Right, yeah. It's the area under the marginal management cost, so it's a management cost. And so we have some costs in this market now that are management costs.